Find the vertex, focus, and directrix of the following parabola. Graph the equation x squared equals negative 12y. Before we work on this question, I want to show you just a few features of parabolas. So I have a picture of a parabola here, which is oriented vertically. And some of the key features are the vertex, which is right here where the parabola changes from decreasing to increasing. Then on the inside of the parabola we have the focus, and then on the other side we have the directrix. We also have the axis of symmetry, which is running along through the focus and the vertex. And notice that that's perpendicular to the directrix. And we also have this lattice rectum line segment, and that is passing through the focus and has 2 points that are on the parabola. We have the orientation that I'm showing you here is a parabola that faces up, but parabolas can also face down, left, right. Actually, you can orient the parabolas anyway, but in this class we're focusing on up, down, left, and right. So we have some equations here, and this first one with it oriented up, you have the squared on the x and a positive value on the other side of the equation. If you put a negative value on the other side of the equation like this one, your orientation is down. If the squared is on the y, you're going to be oriented horizontally, and in this case, because it's positive, to the right. And then when you put that negative on there, it orients it to the left. Now these are all with your vertex being at the origin, but you can move that vertex to any other position by shifting. So we have x minus 8 to shift it h units left or right, and y minus k to shift up or down. So now let's go back to our example. So what I want to know is the orientation of this parabola. So what I notice is that I have a squared on the x. That tells me that the parabola is going to be oriented either up or down. And then I notice this negative, and that negative tells me it's going to be oriented down. Now the reason why this is important to do first is because it's going to help you identify where the focus and the directrix will be. So with a down-facing parabola, the focus will be down from that vertex, and the directrix would be a horizontal line away from that parabola like this. So that's going to help me identify the location of these special features. I also noticed that in my equation, I don't have any values added or subtracted to x, and I don't have any values added or subtracted to y. So that means that my vertex is at the origin, which is 0, 0. So I know that the vertex of this parabola will be at 0, 0. A down-facing parabola will have this equation right here, the squared on the x, the negative attached to the y term, and this negative 4a is important to note. That value of a tells me the distance between the vertex and the focus, and also this distance as well, the distance between the vertex and the directrix. So I need to figure out that value of a. So I'm going to take negative 4a and set it equal to the coefficient on this y, which is negative 12. I'll divide both sides by negative 4 and get a equals 3. So now I know that my focus will be 3 down from that vertex, down because the orientation is down. So my focus is the ordered pair 0, -3. And my directrix will be 3 up from that vertex, and it's going to be a horizontal line. So that's going to be y equals 3 for my directrix. Then finally, the last thing I want to do is to graph this parabola, and it's very helpful to graph the parabola by finding the latus rectum points. It gives you a feeling for how wide the parabola will be. So the latus rectum points are going to fall along the same line as your focus. So I know that my focus is at 0, -3, and the y-coordinates of my latus rectum points will be -3. So what I can do is take my equation, x squared equals -12y, and let y equal -3 so I can find those latus rectum points. So that gives me x squared equals -12 times -3. That's x squared equals 36. I can solve this by square rooting both sides. That gives me x equals plus or minus 6. So I have two ordered pairs for the latus rectum points. That's 6, -3, and -6, -3. I'll plot those latus rectum points. And now I can draw my parabola. Thank you for checking out my videos. Have a great day.